Hello class, and welcome to today's algebra lesson, which is about graphing systems of equations. By the end of today's lesson, you will be able to identify the various types of systems by their solutions and graph in order to be able to determine what those solutions are. So we're going to start by just talking about what is a system of equations. A system of equations is a set of equations, two or more, that have the same variables. So two or more equations that have the same variables. The solutions to these problems are ordered pairs. It is telling you where, if at all, these lines intersect. There are two different groups of systems. The first one is called inconsistent. This is where the system has no solution. The two lines will never touch no matter how far you continue going on the graph. So an inconsistent system has no solution. A consistent system has at least one solution. So there is at least one place where those lines will overlap. Under that, there are two different types. There are the independent systems that have exactly one solution, so the two lines will only crisscross over each other once, or dependent, where the system is going to cross infinite times, so where the points over and over keep intersecting with each other. So what does that actually look like? If we have consistent and independent, so they touch just once, it is going to be a pair of lines, and that solution is where they run into each other. So for this particular graph, they overlap at 2, 4. So your solution would be 2, 4. Infinite solutions, or consistent and dependent, means that it is the same line with two different equations. So the same line, this red line, would go over the top of the blue line, and it would hit at every single point that the blue line hit, assuming that my line was actually drawn straight. The last piece is inconsistent or no solution, and you'll notice that those two lines are parallel. They are never going to touch each other, so they are parallel. So our first piece is just going to be able to identify the number of solutions and then what we call that with the terminology. So for the first problem, we're looking at y is equal to 2x plus 3 and y is equal to x minus 5. So we are looking, in this case, at this blue line equation and at the purple line equation. Now, as we look at this graph, while they do not overlap on the visible part of the graph, if these lines kept going at the bottom, eventually they would cross over each other. So it's not whether or not you can see the intersection on the graph, it is whether they will ever crisscross with each other. So these two are going to crisscross at some point. So we would say that there is one solution. And then the terminology for that is consistent, meaning they touch, and independent, meaning that they touch once. Only one of the answers for the first line is an answer for the second line. If I look at this next pair, so the green equation, this one right here, and the orange equation, this one down here, you'll notice that it is the same line with two different equations. So it's the same line with the equation in two different formats. This means that every single point that answers the first equation is also going to answer the second equation. So this is where we get to infinitely many solutions. And that means that any solution for the first problem is also going to be a solution for the second problem. Once again, they do overlap, they do touch, which means it is consistent. And now it is dependent because every single point on the line is technically an overlap because it's the same line with two different equations. Go ahead and try these two on your own. Looking at red and green, those two are parallel, so they never touch, which means it is no solution and inconsistent. If we look at the yellow line and the blue line, they intersect right here on the graph, so that is going to be one solution and consistent independent because they only touch once. We can also determine this even without the graph. So if you do not have the graph, the key is you want to get your equations into slope-intercept form. So y is equal to mx plus b. The reason that we want slope-intercept form is because that's going to help us determine whether or not they have infinite or no solutions if the slopes match. So if the slopes are different, it's automatically going to be one solution. At some point, they will crisscross over each other. They will crisscross and then keep going in their opposite directions. So if they have different slopes, it can only ever be one solution. If they have the same slope, that is where it is important to be in slope-intercept form because then the b value matters. If it is the same slope with a different y-intercept, that clues you in that the lines are parallel and they have no solution. If it is the same slope with the same y-intercept, that's going to clue you in that it's the same line with two different equation formats, meaning that you have infinite or infinitely many solutions. So looking at a couple of these, my first equation is already in y equals mx plus b format, so I don't have to do anything with that. My second one, I'm going to rearrange, so I'm going to subtract 5x on both sides of that equation, giving me negative 4y is equal to negative 5x minus 9. Then I'm going to go ahead and get that y by itself by dividing by negative 4 on all parts of this equation, giving me y is equal to negative 5/4, negative and a negative are going to make a positive since we have a negative 5 and a negative 4. So I've got a positive 5/4 x minus negative and a negative make a positive again, so it should actually be plus 9/4. When I am looking at my slope then, the slope of the first equation was 4/5. The slope of the second equation was 5/4. Since those are different slopes, that means that they will eventually crisscross over each other. So it would be one solution. And our terminology behind that then would be consistent, saying that they touch, and independent, saying that they only touch once. There is only one point of intersection between these two lines. Go ahead and try this one on your own. Rearranging the first equation using the orange and the second equation using the teal, we find that we're going to end up with parallel lines, same slope, different y-intercept. So this is a no solution and inconsistent system. Now we're going to flip over to actually solving by graphing. When we do this, we're going to want to graph in slope-intercept form. So both of these equations are already in slope-intercept form. So I'm going to start with the first one. And our intercept is 10. So we start at 0, 10. So we put our coordinate there. And then our slope for that one in the first equation was negative 3/1, which would tell you to go down 3 and right 1. So 1, 2, 3, and 1. And then we're going to do it again. 1, 2, 3, and 1. So you want to be very careful now when you are drawing your line that you are holding your ruler steady and that you are going directly through those points so that you make sure that you are accurately graphing the line. I'm going to have to adjust a little bit here since I am on the computer, so bear with me for just one moment while I adjust this line to make sure it accurately goes through my points so that I can get as close to my answer as possible. Again, we want to make sure that we have the arrows on the end of our line to indicate that it goes on forever. Now we flip over to our second equation with our y-intercept of 0, -2. So we're going to put that coordinate onto the graph. And now in this case, our slope is going to be 1 because there was nothing in front of that x. So that tells us to go up 1 and right 1. So from my y-intercept, I'm going to go up 1 and right 1, up 1 and right 1. Once again, you want to make sure that you are using a straight edge and that you are being very consistent in holding that steady as you draw your line, because the accuracy of your answer is going to depend on how straight your lines are. Once again, we have arrows on the end. And now we can find our point of intersection. So in this particular graph, our solution is going to be 3, 1. So that means the point that works for both problems is 3, 1. You can double check your solution by plugging your coordinates back in. So if I did -3 times 3, I end up with -9 plus 10 is 1. If I do 3 minus 2, I also end up with an answer of 1. So as soon as you find that point of intersection, you can plug it back in to double check. Go ahead and try this one on your own. So we have our first coordinate at 1, 0, up 2 and over 3, up 2 and over 3. Our second y-intercept at 0, -6, down 1 and over 2, down 1 and over 2. As you are going through, you find that those lines intersect at -6, -3. Sometimes you're going to have to do some rearranging before you graph. So with this first equation, it is already in y = mx plus b form. So I can start by graphing -3, 0. So down 3. And then my slope of -2 over 1 tells me to go down 2 and right 1. So that first equation was set up so that we could graph it automatically. Again, once you are drawing that straight line, you really need to make sure that you are being as accurate as possible going through those points to make sure that you are setting yourself up to find that point of intersection. And we want to put arrows on the end to make sure we indicate that it goes on forever. Now, our second equation, 6x plus 3y is equal to -9, is not in slope-intercept form, so we're going to have to rearrange that by subtracting 6x on both sides, giving me 3y is equal to -6x minus 9. And then I'm going to divide by 3 on each part of the equation. And I'm going to end up with the equation of y is equal to -2x minus 3. Once again, I would start at 0, -3, and then go down 2 and over 1, down 2 and over 1. As you can see from this graph, the two sets of coordinates lined up with one another. So our solution for this particular graph then is going to be infinitely many solutions. This graph overlaps at all possible points, giving us infinitely many solutions for our possible answers. Go ahead and try this one on your own. Rearranging the first equation and then graphing it, you end up at 0, 1, and then up 2 and over 1 for your second points. Rearranging the second one, you end up at 0, -3, up 2 and over 1 for your second and third points. Those lines are parallel and never intersect, so it is no solutions. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.